Okay, let's move towards problem number 4 from module 1. Okay, here determine the maximum weight W. So we have to find out that W. Okay, that can be supported by two wires as shown in figure. Okay, how it's showing in figure. So here O is a joint, right? O has tied to W. Okay, and O also tied to this point, which is rigid support, and this point. Okay, here are two wires, and wires has some cross section. Cross section is given, and cross section area will be a 200 mm square, and here will be a 250 mm square. This wire will be more cross section, this will be less cross section, but here is a angle given by them. Okay, then what is the next line? If the stress in each wire is not to exceed 120 Newton per mm square, means it's a condition, will be a stress should not be exceed 120 Newton per mm square. Okay, so we have to keep that weight within that permissible limit. Okay, weight means what will be the problem of sigma is formula of sigma. Sigma will be P upon A, right? What is P? P will be a W, right? But W doesn't have a area. But here will be uh, this wire doesn't have area. Uh, this will be area is divided into two different components, right? Two different parts. So by seeing this figure, we can recognize it by Lamis theorem, which will be covered in engineering graphics. Okay, Lamis theorem. This is not in part of syllabus of strength of machines, means this subject. So we are simply I'm simply explaining this Lamis theorem to you. Okay? When it is simple theorem, when three uh, any three forces are joint uh, in a one point, means we are taking example of F1, F2 and F3, and if the opposite angle of F1 will be a theta 1, then F2 will be a theta 2. Sorry, F2's opposite will be this, right? Theta 2, and F3's opposite will be this F3. So in that condition, the forces equilibrium will be F1 divided by sine of opposite angle, means sine of theta 1 is equal to F2 divided by sine theta 2, and F3 divided by sine theta 3. Okay, this will be a relation between that three forces which is passing through a single point. Okay, so here it's same condition. O is a O is common point of three forces, right? Here is a tensile force act on this wire, right? Because W is a pulling force towards the downward. So we don't know W, right? We also don't know this force. So here is area 2 is given. So we can name it as A2, and this also going in a tension. So we named it as T1. So T1 is tension in wire 1. Okay. So if we know that this angle will be theta 1, we can take, and we consider this angle as theta 2, and this will be a theta 3. Here will be uh, also we can write it as t1 divided by sin theta 1 is equal to t2 divided by sin theta 2 and w divided by sin theta 3. Okay, same, right? So if you understand the Lami's theorem, we will move forward to our main problem. Okay, I'm erasing this all, and so we if we solve all the problem on this board, then after solving last step, then everything you appear on the screen will be you have to write it as it is in your answer sheet. Okay, so I am providing you a steps as a question paper. Okay, so, as it is in question paper, so don't miss any details if in my final answer. Okay, so here you can start your answer. First, you have to redraw this diagram. It's called a free body diagram. So consider free body diagram. You have to write this as it is, because I am giving you a exam point of view steps. Joint O. Then here is O. Here will be T2. Here will be T1, and here straight. Sorry, this will be straight, right? So sorry. Okay, this will be W. Okay, we all know if it's acting downward, then it will be 90-degree angle. It will make a 90-degree angle, right? And this angle here provided 45-degree. Means if here is 45-degree, then here is 45-degree, then here is also 45-degree. So here is 45-degree. Then here is 25-degree as per above figure. So here will be 25 plus 45, 40, 50, 60 and 70, right? 70-degree. Then if we subtract this by from 180, then we will get 110-degree, right? Then move forward by using Lami's theorem. Lami's theorem. Okay, you can write it as I shown you before. T1 divided by sin. Here, just check out. We can write. We not need to write theta 1. Here our angle is given. Okay, which is given. We can write it simple as so 90 plus 45, 135 degree. 135 degree is equal to T2 divided by T2's opposite angle will 90 and 25. Sine of 90 plus 25, 115, right, is equal to W divided by sine of 110-degree. Okay, next. So we just combine taking the W with T1 and W T2 on W with T2. How can we take this T1, this sine 135, we can multiply it here and take t1 is equal to sine 135 degree to w divided by sine 110, right? You understand? How can we write it? Same we can do it with a t2 sine 115. We can multiply it here, right? So this we can calculate it in a natural number by using a calci. Sine 135 divided by sine 110. You can use a calci and you can calculate it. Yeah. So here will be t1 is equal to sine 135 divided by sine 110. It will be 0.752 W. Okay, you just confirm and recheck by your own. Okay, don't rely on my notes. T2 is equal to, if we take this in multiplication, then we can directly calculate it by calculation and directly return here 0.962 W as it is. Okay, these two equation we got. Okay, then how can we find stress? So we cannot find stress here, okay, of W, because when we look here, whenever we consider a bar, here is any rectangular circular bar, if we consider a pulling force both sides, then we take a cross section of this, right? Cross section of this. Why we take this cross section? Why we not take this cross section or any here we can cut and take this cross section? We don't do that. Okay, why we don't do that? Because we need to take a cross section of perpendicular side. Okay, so here is W is perpendicular to this, right? But here is no any cross section given, as here is no any wire or anything. So if we have a cross section of this, then we can't consider it because it is not directly 90 degree, right? So we are not taking it. So we are using a Lam's theorem. Okay, then but if here is tension, okay, then here is a pulling force T1, then T1 has a exactly perpendicular cross section, means it's a simply the bar is like this. Okay, bar like this, and it program it's provided here a tension, so T1 pulling it by T1. So we can take this cross section. Okay, so for the sigma formula, what is sigma formula? Sigma is P upon A, right? So for that P upon A formula, if we taking some P, then the A will be directly perpendicular to that P, right? So here is T1, so perpendicular, we can take a cross section at A1. Okay, so we can find stress, means we can find the stress of that wire only. Okay, we can't find stress of that W. Here stress we can't be find. Okay, so stress means we can find also stress in wire, this wire also. Okay, so we first take stress in wire 1. What will be the formula of stress? Stress is equal to simple formula T1 divided by, if you understand this perpendicular etc concept, then it will go very easy for you to imagine that all. Okay, so sigma is equal to T1 divided by A1. So sigma is they have given us a limit to not exceed 120 Newton. Okay, so we can directly take it as it is. It's equal to T1 we have had in the equation 0.752 divided by A1 is given value directly is 200. All values are there, so we can find W directly by LQ. Calci will be 31915 Newton. Okay, then it is not a final W value, means weight value. They have told us maximum weight can be possible. Okay, so we have to compare it by calculating stress in wire 2 also. Okay, so take a same formula for sigma. Sigma has always a P upon A, right? It will never change. Okay, P is here T2 and A will be A2. So sigma is a limit, common limit 120 degree. They told us not to exceed it. Okay, T2 is by uh, above equation 962 W divided by A2 will be 250. Okay, calculated 31120 Newton. Okay, here is another W we get. Okay, let's see what is happening here actually. Okay, what is happening here? If we found two W's, then uh, which W will be a correct answer? Maximum weight. What they told us, maximum weight that can be supported by two wires. Okay, so are we taking a maximum of both the value? What? No, right? We can't take if they told us take a determine a maximum weight that can be supported. But here in both value there is a maximum value will be a 31915. Okay. What is they given? They need to satisfy their condition, which is wire is not to exceed 120 Newton per mm square. Okay, so simply take an example. Okay, here I'm here. Okay, yeah, here I'm redrawing it, and here will be T2, here will be T1, and here will be W, right? So first W will be 31915. It is produce stress on wire T1. Okay, W will be 31915, and its produce stress on wire T1 will be 120 Newton per mm square. It's it. Okay, if we consider this a load, then uh, this will exert stress in that first wire will be 120 Newton per mm. Okay, we don't know how much stress this load and so this W can be produced in that wire. Okay, and so this load will be producing 120 Newton on this wire, or same load at a time producing uh, number of loads in number of stress on this wire also. Okay, but we don't know the exact value. Okay, let it be. Okay, let it be. We move forward. We take another load value. If we consider load, will be applied load 31120, then this will be generate a stress in this wire will be 310 Newton per mm square, because we found the value of W 31120. How can we find out that value? By taking the stress in wire 2. Okay, taking in consideration stress in wire 2. So we found this load. Okay, so when we apply this load, then definitely the 120 Newton per mm square stress uh, will be generated in this wire. Okay, we at the same time some stress also generate in this wire with this load also. Okay, are you getting my point? But we don't know that exact value. Okay, just now you will be clear everything. Okay, here is just take an example. Just take an example. Here is W value is 31120. Just imagine simple thing. If we increase this load, means 31,000 load, right? We increase it by some thousand, means we increase it by 32,000. It will make it at 32,000. What will happen to this stress? Stress will increase or decrease. If load increase, stress also increase. Okay, stress will also increase, right? Means if we here is 31,120, if we make it 31,915, means increase, right? This will be higher value. So this load, this stress also be increased. Okay. Increase means we are taking, for example, just higher value from 120 Newton. So we taking it as 130 Newton per mm square for example. Approximate it will be 130. Okay. Then come to the wire number 1. Okay. Here is 31,915. We know exactly when we apply this number of this value of load, then it will be generate 120 Newton per mm square. If we think if we decrease this value by some thousand, means 31,915, right? Then if we make it 30,000 or something, then what will happen to this load, this stress? It will also be decrease, right? So another example, if we take it 31,120, which is similar to this value. Okay, it is decreasing, right? So it's also be decrease. Means if we consider some approximate stress, so 120 its lower value will be 110 Newton per mm square. If we apply 31,915 Newton on this wire, then it will be 120 Newton, and 31,120, then it will be 110 Newton. Okay, for the wire number 1. So what they uh, told us, what are their conditions? Stress should not exceed 120 Newton. Is it exceed? 110 is in a limit, right? It's not exceeding. Here we can produce any stress, means 100 or 90 N Newton per mm square. Any will be permissible, which is a value lower than 120 Newton. Don't they not they have not said to us keep it exactly as 120 Newton, right? They told us not to exceed above 120 Newton. So we are within a limit. Means if we take this value, we are also satisfying the limit. If we take this value, we also satisfying the limit or condition for wire number 1. Okay. Now here uh, take a wire number 2. Okay. If we take a load 31,120, then the stress value will be 120, and if we take 31,915, stress value will be 130, which is not permissible. Means 31,120 is permissible in both conditions, 31,915 not permissible in one condition. So yeah, we can't take this value, we will be take this value. So if they have told us to decide a load, safest load, so we have to take always a lowest load. Okay, and this is the maximum weight possible. Means the maximum weight can be supported. So here you have to write hence maximum weight W is equal to smallest value of W. It will be 31120 Newton or 31.12 kilonewton. That's all. Thank you. Okay. Here is no any homework.